nuclei within the pons. Okay? Those fibers travel from cortex through the cerebral peduncles to get to the pons, along with corticospinal and corticobulbar fibers. Okay? So that's cerebrocerebellum. Then we have this midline, inferiorly or posteriorly, we have this midline groove that then becomes sort of this midline ridge. And that's the vermis. And on either side of the vermis is something referred to as the paravermal zone. And then you can't really tell where that is, but just around here. That paravermal zone plus the vermis is the spinocerebellum. It's more attuned to receiving information from dorsal spinocerebellar tract, cuneo-cerebellar tract, and really the specific components of spinal cord activity. Okay? And then finally, the last component is the vestibulocerebellum, and that's represented by this small piece that's stuck out here to the side, and that's the flocculus. So there's a flocculus on this side and a flocculus on this side. And then when we look at the midline component, here's the vermis right here, and all of this is spinocerebellum until you get to this very last piece right here, which is the nodule. And the combination of the flocculus on both sides plus the nodule is the vestibulocerebellum. Okay? Now remember that each one of those functional divisions was defined according to kind of what part of movement, what part of the central nervous system it really had some control and relationship with. But the output of all of that cerebellum was by way of deep cerebellar nuclei. So then what I did was I took this cerebellum and I cut it. And I shaved off the top of it to the point that we could now look at the internal structures. So on this side, what you can see is this darkened area right here, and that's the dentate nucleus. So that's representing the deep cerebellar nuclei specific for cerebrocerebellum. And you can't see the others. You can't see interposed or fastigial nucleus. But what you can see out of that is the fibers that are leaving there and heading towards the midbrain, which is the superior cerebellar peduncle. Okay? So primarily an efferent pathway. Then I shaved off a little bit more on either side. And now what we see is on this side we just see this large bump to the side, and that's the middle cerebellar peduncle. So that's representative of all those transverse pontine fibers that received cortical information to the nuclei, and then from those nuclei gave rise to these fibers, and that's the middle cerebellar peduncle. You can see this ridge on the side of the brainstem, on the side of the medulla, and that's the inferior cerebellar peduncle. So that's the ridge, that's the fiber pathway bringing in all of the direct fiber information from the spinal cord and the vestibular system and the olivocerebellar fibers that are climbing fibers. That's how they all get in there. So they have inferior cerebellar peduncle, middle cerebellar peduncle, and let's put this back this way so you can see them together. So inferior and middle, and then superior cerebellar peduncle, coming out of the deep cerebellar nucleus. Now, usually defined as afferent systems are the inferior and the middle cerebellar peduncle, and the primary efferent pathway is the superior cerebellar peduncle. But remember that the inferior cerebellar peduncle has some efferent fibers to the vestibular system, and the superior cerebellar peduncle has some afferent fibers from the ventral spinal cerebellar tract, which is a tract that starts on one side of the spinal cord, integrates a lot of information, crosses to the other side, ascends through the brainstem, and then finally those fibers cross back to get to the same side of the cerebellum where that information started. So that gives us that functional ipsilateral relationship. In other words, the cerebellum is concerned with all the sensory information that's coming in from the ipsilateral side. Okay? So That's kind of what we need to go over again and again and again to get a comfort level. Okay? So are there any questions? Is it a fact that you have no idea what to ask?
Yes.
Fine. Fair enough.
Hey, Cliff, it was the flocculus, and was it the nodule?
The nodule is this midline piece right here.
Okay.
So it's really unpaired. It lies right on the midline.
Oh, okay.
And the flocculus, there's a flocculus on either side. So one here and one here. And when you look at it drawn out, it's kind of a whole strip of the cerebellum that crosses the midline, and is referred to as the flocculonodular lobe. So that's where an anatomical definition matches one of the functional divisions, but the other parts don't. So spinocerebellum there's an anterior and posterior lobe. Spinocerebellum is part of both of those. The lateral cerebellum has an anterior and posterior lobe. It has part of both of those, but it's cerebrocerebellum. So we want to really focus on the function and what they're related to in terms of movement and control of movement and modification of movement, and not worry so much about the anatomical definitions. Okay? All right? Yes.
Could you just say the cross of the last part of the spinocerebellum, the ventral
Ventral spinocerebellar pathway?
Yeah.
Okay. Now remember that there were two, there are really four, but I only described two. When you look at the spinal cord, there are two spinocerebellar pathways. There's a dorsal spinocerebellar pathway and a ventral spinocerebellar pathway. The dorsal spinocerebellar pathway carries very specific proprioceptive information. It's exact same information that travels over the dorsal column system. So it's the muscle spindle information, it's the Golgi tendon information, it's the joint capsule information. Everything that we use to understand spatially where we are. That goes direct, with one synapse in dorsal nucleus of Clark, goes directly into the cerebellum. The ventral spinocerebellar pathway carries a very integrated message. So that axon arises from a neuron in the dorsal horn. And that neuron in the dorsal horn is receiving that same incoming sensory information, but it's receiving information that's coming down from the cortex through corticospinal system. It's receiving multi-segmental information through propriospinal tract, which is that long tract that interrelates all the segments. And it's getting all of that kind of information, and it's converging on single neurons. So that's a very complex piece of information instead of being true to one modality. That axon then crosses the midline, turns and ascends through the spinal cord as the ventral spinal cerebellar tract. But when it gets up to the midbrain, that axon then makes a U-turn and goes back across the midline to then enter the cerebellum back over here. So while it still goes in as a mossy fiber like all the other things do, it's carrying not specific information, but a very integrated piece of information of what all is going on at the spinal cord at that level. It's a convergence of motor, sensory, intersegmental kinds of things. Okay?
Where is the synapse between the first set of information before it crosses over and then goes up?
It's in the